Hey everybody, my name is Timothy Karambet, co-founder of Mintplex Labs and creator of Anything LLM. This is part 2 in a 2-part series of basically how to run the Chroma open source vector database software on AWS, but in a more secure format. So the first video focused on how to set up Chroma, what is Chroma, how to run it locally via Docker, and also how to set it up on AWS semi-privately. If you refer to that video, you'll see that there is kind of a security issue where if someone knew the IP address of your EC2 instance on AWS running Chroma, they could connect to it and reset your entire database. There was a solution where you could put an API gateway in front of that, but that does not eliminate the attack vector of someone connecting to your public IP EC2 instance and resetting it that way. So the second video is actually going to show you how to set up a truly private and isolated EC2 instance running Chroma in basically a private subnet on AWS. It's not that complicated. That being said, I am not a AWS solutions architect. And so if someone has a faster and cheaper way of running what I'm about to show you, please leave it in the comments or just make your own video and just refer to this one. I would love to know if there's a simpler way because this was absolutely painful for me to discover. So here we are on Anything LLM's GitHub repo. This is just a full stack application. You can plug a Chroma instance that is running locally or on the cloud right into the application and you can use Chroma. Now, again, going back, what is Chroma? Chroma is an open source vector database. Now, this is a really awesome tool. They give you the ability to run it locally and also have a CloudFormation document or template that allows you to run this on AWS if you have an AWS account very easily. You can find this on their docs under the deployment tab on the sidebar, and they have the template URL here. In the previous video, I showed how to use this template URL and deploy this public stack on AWS. I've already gone ahead and done that because that is a good jumping off point for how to turn this into a private instance. So if we look at my EC2 instances, we'll see I have a public Chroma instance that is running. And if we were to go to CloudFormation, you will see that it was created using the Chroma stack template. However, what we actually want to accomplish today is how do we get this public instance behind basically a private subnet that doesn't have inwards internet accessibility to where the only way to get to it is through an API gateway that may or may not be authenticated. And the reason for this is because you just don't want to have a EC2 server floating out there with an IP that anyone can connect to and essentially drop your entire vector database and all your hard work. So let's get started. And the first thing we need to do is actually create a VPC and some subnets and all of this. By the way, just to preface this, this isn't an extremely costly operation to run month to month. I think the traditional Chroma stack that is public is about $15 a month, most of that being the EC2 instance that has to run on a T3 small. This is going to be a little bit more than that, probably around $20 a month, depending on bandwidth and volume. And also what we're setting up today will support a single instance. That's pretty much it. So as I said, first thing we want to do is create a VPC. So here we are on the VPC screen. We're going to go to your VPCs and you should have a default VPC here. And we're going to click create VPC. We want to create only the VPC for right now, just for simplicity reasons. And we're going to call this private VPC. And we're going to give it a default block of, let's do /24. Why not? And, we can give it a tag or whatever. And yeah, we don't need IPv6 for this. Okay, so the VPC is creative. There is a default route table that we actually won't be using. And you'll notice we have no subnets and no network connections. Now, the overall goal of what we want is we want our EC2 instance, our Chroma EC2 instance to be in this VPC and be able to reach out to the internet because it needs to be able to download its image essentially during the build process. But we don't want the internet to be able to reach back into the private subnet to be able to reach our instance because then anyone can do that. We only want this instance to be reached through the API gateway and only by the API gateway. And It's going to get a little bit complicated, but if you follow step by step, I promise everything will work out. In this VPC, we're actually going to create two subnets, one public and one private. The public subnet will have a NAT gateway on it so that our private subnet can reach the internet, but the internet cannot reach back. The reason for this is because the instance will be in the private subnet, but it needs to be able to reach the internet to download its information and its image so it can run. The other thing is that in this private subnet, we will basically have a network load balancer that points to our instance, and then the API gateway will use a thing called the VPC bridge. Just follow along and it'll make sense. So let's start creating our subnets. So what we're going to do is actually, before we even do that, just for simplicity reasons, I am going to go to the VPC and I'm actually going to add a CIDR block. And we'll just call this one 11.0.0.0/24, and we're going to save that. So now we have two IPv4 CIDR blocks. Then we're going to go into subnets, and we're going to create two subnets. We want to select our private VPC, okay? And this is where we're going to create our public subnet. And we're going to put this in US West 1A. I'm going to paste it in there. And now, ideally, you want to have actually dual zone availability, but for simplicity reasons, because frankly, if you're running this private instance, it's probably not going to be doing an insane amount of bandwidth or traffic, and you're not going to have like 5,000 instances in the subnet, so you should be fine. But we're going to do private subnet, and then we're going to do US West 1B, because that's the area I'm in. If you're in a different zone, you would have different options, but just split it across AB zones. And then for this one, we're actually going to do the 11 block. Create subnets, and we are good. Now, we need one more piece of the puzzle. We need an internet gateway. So we're going to create an internet gateway, and we're going to call it private gateway. Let's do like private VPC gateway, or IGW for internet gateway. And we're going to create that. And so now we have an internet gateway. It is not associated with a VPC, so let's select a VPC to add, which, by the way, this is our private VPC. So we're going to attach this internet gateway. If we go to our VPC, this is a cool new thing Amazon has, and you'll see actually from our VPC that we have both subnets pointing to the default route table, which then does not reach the internet gateway right now. We want to actually split each subnet into its own route table for simplicity reasons and only have the public be reachable to the gateway. So the way to do that is, first, we would actually have to create a route table for our private subnet. So we go to route table, create route table, and we're going to call this private route table. And we're going to select our private VPC, and we're going to create that. And then you will see that this one is just basically a dead end. And that's what we want to do. We want to then actually have it associated with our private subnet. So we're going to save that association. And now if we go to your VPCs and we go to our VPC, you will see that the private subnet goes to the private route table, has no internet access. It's just locally referring, which is what we want. We're going to go to the default route table now. And that is when we are going to edit the route, add all IPv4 traffic to the internet gateway that we just created, and save changes. Now, let's go back. I told you this would be, this is a lot of stuff. This isn't even the hard part. So we now have our public subnet going to the default route table that is now reaching the internet. Then we have our private subnet that is going to a private route table that does not have access to the internet. Instances we add into the private subnet should only be able to reach outbound to the internet, and the way to do that is through a NAT gateway. So the NAT gateway will basically bridge these two. I guess it will allow private to reach out to the internet through the public gateway. Subnet. So we're going to go to NAT gateways. Now, NAT gateways are where expenses might be incurred. They are basically paid per hour. It's not very much, and they need an elastic IP address, which that also, it only costs money if you're not running your instance. So if you pause your instance in this entire piece of architecture, you will incur a fee. So let's go to create a NAT gateway. let's just call it default NAT Gateway. And we want to select our public subnet, the one that is that we know. This is going to be a public connection for the NAT, and we're going to need to allocate an Elastic IP, and then we're going to create the NAT Gateway. This process does take a while for the NAT Gateway to spin up, so we will pick back up once this is created. Okay, so our NAT Gateway is now in the available state, so that means that now we can use it, and the way that we use it is we actually have to revisit our route tables. To make this really visually apparent, we're going to go to the private subnets route table. We're going to go to here. We're then going to want to edit the routes, and we're going to want basically all traffic to go to the NAT Gateway. And you can see that this was the default NAT Gateway that we just created in the previous step. Now that we have done that, if we go to the private VPC and look at the map again, you will now see that we're actually reaching the default NAT Gateway. Excellent. The next thing that we're going to need to do is going to be creating a target group that's going to put our instance in it. So how do you create a target group? You actually have to go to the EC2 side of AWS. We're going to go to target groups, and we're going to create a new target group. This one, we're actually going to be targeting instances. We're going to call this our PRIVATE Chroma instance. And we're going to want to target TCP port 8000 because the Chroma instance runs on port 8000. And we're going to want to put this in our private VPC because that is where our instance is going to run. And for the health check protocol, we can do TCP or HTTPS, or don't do HTTPS, only HTTP. And for this, we can actually just do API/v1, which is actually going to return a 200 response. And for advanced health check, we're not doing the regular traffic port. All traffic goes to 8000. So make sure for this health check, you override this, because if your health check is failing, all of this will not work. So that's a good way to know if you set everything up properly before you really dive deep into this. And we expect to receive a 200 status code from that. So let's create this. I did not add hyphens, so all right. And now it'll show you that we have no available instances. That's fine. We'll register one in a second. So just create the empty target group targeting TCP 8000. And now it is time for us to launch our Chroma instance into our private subnet in our private VPC. So the way you do that is go to instances. Now, because I used the available Chroma CloudFormation template to launch this instance, there's an easy way of duplicating this exact instance by just clicking on this box, going to Actions, Image and Templates, Launch More like this. There's an easier way to do this because you can take actually a image snapshot and then you can just keep spinning up images. I'm doing this from a live image. We can kill the public one after. Whatever way you want to do this, you just want to duplicate what was created from the CloudFormation template that Chroma provides. All of this, leave it as it is. You want the T3 small because again, you need one. Key pair, we're not worried about that because we're not going to SSH into this. This is where we want to actually modify information. We want to put this into our private VPC, and we want to put this into our private subnet. We do not want to assign a public IP, and we want to actually create a security group for this. We're going to call this PRIVATE Chroma SG. And for this, it asks for a default security group rule for port 22. Because we're not SSHing, I'm actually going to remove this. And actually, let's do a custom TCP on port 8000 and allow all traffic to be able to hit that port. Because this is in the because this is in the private subnet, this isn't really a problem. And that's it. You can close the advanced network. The default volume size, by the way, is 24. If you know you're going to be storing a lot of information, your mileage may vary. This is your call. But anyway, we're going to go to launch instance. It's going to say, hey, you should add a key pair. We don't care about that. Proceed without key pair. And then you're going to have to click launch instance again. Now, this will only take a couple minutes to spin up. And if we go to instances, you will see that this is pending and now it's running. That was very, very quick. Status check is initializing. We're not really worried about that. This, actually, we want to rename to private Chroma instance. This is our private instance, not our public one. And you'll notice that it has no public IPv4, DNS, or address. All right. Now that we've made it this far, we need to add this instance into the target group we created previously. So we're going to go down to target groups. We're going to open up this group. We are going to register a target. We have one instance, so that's the only target. So basically 100% of traffic that comes into this group is going to go to this singular instance. Include as pending, register pending target. And what we're going to do next is create the load balancer so that we can basically make sure that the status checks work here first. So next, we need to make a thing called an NLB, a network load balancer. This basically handles traffic on the network layer to point it to this target group so that any incoming traffic internally can be pointed to this singular instance that does not have a public IP address. All right. I'm sorry, but this is, you can't imagine how kind of like frustrating this is to do this manually, but it does work. So I guess this is what we got. So first we're going to create a load balancer. We want to create a network load balancer, and we're going to call this Chroma NLB. This is going to be an internal load balancer on IPv4. We are going to put this in our private VPC, and it will only be mapping to our private subnet in here. And we will just get a range within that. Now, again, TCP 8000 forward to the private Chroma target group that is that singular instance. And we don't need any tags or anything like that, so let's create this load balancer. Now, creating the load balancer, again, it is provisioning. It takes anywhere from like 3 to 5 minutes, so just wait a couple minutes, refresh the page, and until this is green, do not proceed. Okay. Our network load balancer has finally been provisioned and it is marked as active. We're going to jump into this and we're actually going to see that we are forwarding to our target group that we had created that has our single instance in it. We're going to jump into the target group and you will see that we are actually getting a healthy response. This is perfect. If you are not getting a healthy response at this, you probably did not set the port correctly to 8000 for TCP, or something else with security groups. Basically, it should be port 8000 across the entire stack that we're building right now. If you didn't do that, or you assume something, or maybe even your health check is not hitting port 8000, that is why it is marked as unhealthy, which also means that your instance is not going to be responding. Okay, so we just created a technically private Chroma instance that nobody else can access. In fact, we can't even access it. So how the hell do we reach it now? Well, that is when we put the API gateway in front of all of this. The API gateway is essentially the giant doors in Jurassic Park, and only traffic coming through those doors is going to be allowed to reach our instance. How do we do that? Because we have this network load balancer in a private subnet. AWS has a feature called a VPC Link. It does exactly what you think it is. It's basically a link that allows you to talk to network load balancers in a private subnet. It's actually purpose-built for that. So what we are going to do is go to API Gateway, and the first thing we're going to do is make a VPC link. So the way to do that is actually do it through the sidebar right here, where it shows VPC links. We have none available, so we're going to create it. We're going to choose VPC link for REST API. We're going to call this NLB VPC link. And you could put Chroma, just if you have multiple that you're planning on doing. And we're going to choose our Chroma network load balancer that is in our private subnet in our VPC. Click Create. Now, they aren't joking where they say this process may take a few minutes. It legitimately does. So again, you are now waiting. But in the meantime, there's actually something you can do, and that is basically just go to APIs, and we're going to create a REST API. And this process is actually extremely similar to the process of creating or putting an API gateway in front of the public Chroma stack. So we're going to call this one, and we're going to call this Chroma API. And it's regional. We don't have to do edge. So create the API. Now we have a blank API, but until our VPC is created, we cannot use it yet. But we can go and create the resource. We're going to do a proxy resource here. And you will see the option is here for VPC link, but nothing is possible there because our VPC link isn't online. There is some stuff we can do in the interim though, like for example, creating our API key, which I have already gone and created, and it is associated with a basic usage plan. I did this in the other video. This isn't difficult to do, just go do that. When you go to usage plans, you'll see that there are no API stages. So basically what we are going to do is once we are able to connect our VPC link and forward traffic and test it, I'm just going to deploy it to a stage, put that stage in this usage plan, and now you can use the API key on that. It'll be step by step. Just give it a second. I'll come back to you whenever the VPC link is live. Okay, so that was probably like 10 minutes. And I think it's because they actually had to call up Jeff Bezos and have him go run a wire across the data center to connect whatever it is the hell that they had to connect. And that's why he's so fit. Anyway, the VPC link is live. So let's add it to our gateway. So of course, go to your gateway that we created in the previous steps. And we're going to go to proxy. Nothing is set up. Again, if you want to have a granular approach to how data is written or read or both, you can subtract out the methods here or call them out specifically and add different keys or authorizations. We're just going to apply this blanket statement to everything, and we'll have no API key at first, and then we'll add one later. So we want to do a VPC link, so we're going to click that. It's going to be a proxy integration, and it's going to be our VPC link. But you're probably wondering, what the hell is the endpoint? We don't have an IP like we did in the previous step. This is actually easily solvable. You would go to your network load balancer, which can be found in the EC2 panel. Go to load balancer, go to the Chroma, NLB, and then we want to copy this DNS name. We're going to go to here, we're going to go to http:// that. Don't forget port 8000, and we are going to proxy so that anything that comes after that, just forward it on straight to the interface, to the instance. We're going to click save, and now we have a method request that no API key is required, and it is using our VPC link. Any method's fine, and it's pointing to this endpoint URL. So before we deploy, let's test it. So in order to test it, we'll go to test, we'll go to get and API v1, and let's test. Hooray! We get the nanosecond heartbeat response, which means that this request was actually forwarded to our Chroma instance, and now we are good to go. And actually, if we want to go a little bit further, we can do collections and test that, and we get an empty array, which is what we're supposed to get. So we know everything is working. Now, what we need to do is deploy it, and we'll deploy it without an API key, and then we'll add the API key, and we'll test it all in Postman, or you could curl it if you want to, or anything like that, but let's do that. So, actions, deploy API. We're gonna call this new stage, because we don't have any stages right now, and we'll call it priv. You can call it whatever you want, doesn't matter. All right. We now have our API endpoint, and if we go to it and now paste that address in, obviously if we run get right now, we're going to get a random error because that's not a real URL. We want to do /API/v1, and we get our nanosecond heartbeat. Keep in mind, we have no key header here. If we go back to the console, go to resources, go to proxy, go to the method that we want to authenticate, go to method request, and then require an API key authorization, redeploy this API to that stage, go to our usage plan. I'm sorry, I know this is a lot, but go to the basic one, add an API stage. If you don't have a usage plan because you're following this video for the second time, just create one. It's not a big ask. And we won't implement any kind of throttling or anything, but you can if you'd like. And you know what? Just for safe measure, let's just deploy it again. It doesn't take much to do. So, all right. This has been deployed. We've got this really funky URL. You can do custom domains, by the way, but that's out of scope for this video. And so here we are. Let's send a request. We have no API key set, so it should fail. And it did. Now, the next thing is send an authenticated request. So to do that, you're going to need a API header called API key, X-API key. And we'll go to API keys as we already have, show, and we get our nanosecond heartbeat again. That's it. That's pretty much the entire process. I will go through tearing it down next, but basically what we just did is we have a Chroma instance that is running on a private subnet that is not accessible to the outside internet, but that it can still access the internet to pull in its image because it needs to do that to run. And yeah, that's pretty much it. So now the only way to reach your Chroma instance is by hitting this API gateway URL with your authenticated token. And until somebody figures out what this URL is, which isn't that hard, and also knows your API token, which they should hopefully never know, then you have a protected Chroma instance. Go crazy. And again, you can integrate this into whatever tool you might be using with Chroma. Now, we need to tear everything down. So the first thing that I want to do is let's just delete this API key, which I don't think it'll let us. Okay, no, it did. Okay, cool. Let's delete the API key. We'll go to the API, and also let's delete this usage plan because we're not going to be using that anymore. So delete the usage plan. The API key stage is associated with it. All right, let's go to API keys. Let's go to stages, go to priv, because that's the one we did. Delete the stage. All right, then go to go to usage plans, and then we're gonna go and delete the usage plan. And now if we go to APIs, we can go and delete our entire API. Again, now we have made our instance inaccessible. Don't forget that thing that took 20 minutes to set up. We're going to delete that now. So we'll delete this VPC link. And now we are done. We have now wiped our API off the face of the planet. Let's attack the next part of the problem, which is going to be the network load balancer and the instances. And then finally, we'll tear down the VPC. We're going to go to this target group in our network load balancer. That's what that was, by the way, if you didn't know where I landed. I was in the Chroma NLB load balancer that we created. I jumped into the target group. We are healthy, but we're going to deregister our instance, and it's going to show a health status of draining for a second, and then eventually it'll just unpair from the target group, and then we can delete the load balancer and then the target group. You got to go back and forth. Okay, so our target finally deregistered, and so now we can go back to the load balancer, go to the Chroma NLB, and delete the load balancer. Now that the load balancer is gone, we can go to the target group. You will see the target group is unassociated and there are no instances in it because we already removed them. So we'll go and delete this as well. And now we are done with that. And the last thing to clean up is, of course, the private Chroma instance that we are running. We'll go to instance state and we shall terminate it. And this will successfully have killed the private instance. All that's left now is the VPC work, which actually isn't as hard as it sounds to get rid of. While the instance state isn't shutting down, we can actually just go over to the VPC side of things. We'll go to our VPCs. And so we see we still have our private VPC running. The first thing we need to get rid of is the NAT Gateway. So let's go to NAT Gateway and let's delete the NAT Gateway. NAT Gateway is now deleting. There is one thing that is actually going to remain when you delete the NAT, that Elastic IP address that got associated with it. So if we go to Elastic IPs right after we just delete that and we try to release this address, you will see that it cannot be released. Once the NAT gateway is fully deleted, you can release this IP and then you will not be paying for it. It's per hour, so if you delete it in less than an hour after it's been unprovisioned, you'll be fine. Next thing is actually if we try to go back to the VPC and try to delete it, it still shows that the NAT gateway is there. So we're pretty much in a holding pattern until this NAT is fully closed. Okay, now that our NAT gateway is in the deleted state, there is something that remained behind, and that was the Elastic IP that was tied to it. So let's go and release that IP so that we don't have to pay for it, because Elastic IPs you have to pay for if they're not doing anything. And then I believe all that should remain is that there is an internet gateway that we need to remove. So let's go to the internet gateway and detach the private VPC gateway. So we'll detach it from the VPC. And now that that has been detached from the VPC, we can delete it because we no longer need it. And it's of course going to make you do all this stuff. All right. And now, last but not least, we go to the private VPC, actions, delete the VPC. It will delete the subnets and the route tables that we made that were associated with this VPC. So type in delete. And now that our VPC has been deleted, there's really only one other thing to clean up, and that's actually not even really part of this video, but it was the stack that I used that I cloned to make the Chroma instance again. So we're just going to delete that because why not? So we'll delete the stack. And once this stack is deleted, we should pretty much be reset to a clean AWS account. Obviously, if you have other stuff running on your AWS account, this would not have deleted them. It's just that this account that I'm using right here, it has nothing on it. So I figured it would be a good example because there's nothing else to really kind of look at or get confused with. And just like that, our stack was deleted and there really is actually nothing left. We go to our instances. We have no instances running. I have a snapshot from something else. And then if we go to our security groups, we should just be left with our default security group. So that's it. We are reset to nothing. Again, if you had other resources running, they wouldn't have been impacted by this. And so with that, I will leave you. That is how you can spin up a single instance Chroma vector database fully protected behind a private subnet in a VPC that you control, where the only entrance is through your API gateway, unlike the public template that they provide, which allows people to be able to, if they know the server's public IP, interact with it. This eliminates that attack vector. You now have a secure database instance. Again, I want to close off this video by talking about the fact that they will have a roadmap for hosted Chroma, which will be less of a single instance Chroma that we had just deployed, and will actually be a production ready database. But that looks to be coming towards the third quarter of 2023. So until that happens, this is a temporary solution to get you spun up quickly, but feel a little bit more secure that your vectors are safe and that people cannot delete or read from them. That's all there is. And so with that, I leave you. Thank you. If you have any questions, drop them in the comments. And yeah, happy building.